So good evening all. We can wait for 4 5 minutes. After that, we can start the class. Okay, so I think we can start the class. Let me share the slide. After that, we can start. Okay. So I think my screen is visible to everyone. So let's start. So good evening all. So myself Swankar Mandal from Indian Institute of Science. So I am one of the TA of this online certificate course. The title of the course is Electrochemical Technology in Pollution Control. So the course instructor is Professor J.R. Mudakkavi, and I used to work on the solid state and structural chemistry unit on electrochemistry battery, basically on the battery energy storage. So in particularly, I used to work on metal air battery. So today we'll discuss more details about battery. So whatever we have, okay, this is the outline or contents of this course. So almost we have done all the things. So today, although it is a extra class, but I believe that if we discuss okay, today the last part, that is battery technology and fuel cell also. So then we can okay, summarize in Monday class whatever we have done. So that thing one by one okay, we can okay, recall all the part in short term so that in exam if people can write all these things or remember. So that is the motive of the course. So for this today we'll discuss the last part, battery technology and fuel cell. So one of the small part also there, that is okay, zero liquid disposal. So that things also we'll discuss. Okay, so what we have discussed last class. So last class we have discussed how to dispose the sludge. Basically, after electroplating, whatever the waste material is to produce, so that thing how you can handle. So and electroplating part we have discussed the metal preparation, how to okay, do the thing. So basically during the electroplating, what you have? So you have one anode. This is suppose anode and this is suppose cathode, which are separated by the electrolyte. Okay, so these things is there. So to do that thing, so electroplating process, we have discussed how to do the electroplating process and how electroplating is to work by two electrodes which is close to each other, and you can do the electroplating on the cathode as well as anode. And some of the electroplating method or different type of materials we used to plate on some other materials or some other substrate. So that is some of the things is called brass plating, chromium plating. So in the plating we have learn hard chromium plating and soft chromium plating, and nickel plating, copper plating, zinc plating, silver plating, tin plating. So all these things we have discussed, and for that, what are the electrolyte we have to take? That things also we have discussed. And also we have discussed some of previous year question, assignment question, and some of the problems from CSIR UGC net, or I think 2015 and 2014. So I can, if Monday, if we get time, then we can discuss 2, 3 problems from the previous year question of CSIR UGC net. If and also Monday, I think today, if I get time, then I can show the some experimental data of how to do the cyclic voltammetry. So that video we have. If today I will not get time, then definitely Monday I will show the instrument and some of the what is called potentiostat what we have in our lab. So that picture also I can show, and how to do the experiment. That video okay, I will show maybe on Monday. So that things I will show in the Monday, and today we will discuss first the assignment question, and along with that, before doing the assignment question, some of the part related to that assignment, that thing we can recall, then we can go to the that question. Okay, so this is the first question. So GLD, zero liquid disposal, is a method for pollution control for solids, for liquid, for gases, and for hazardous waste. So if people can write in the chat box which one will be the answer. Okay, so that. Okay, I can see the chat box. So this is basically zero liquid disposal. I think we already discussed this thing. So if we did not remember, then I can what is called just recall all these things. So basically, this GLD or zero liquid disposal, that is apparently first born at 1970 century. So it is in USA first it is invented. Basically, the tight federal regulation of salt discharge to surface waters introduced especially due to the salinity problem in the Colorado River. So there, what is called there is means salt water is to there. So but there we need the drinking water. So which for this we need to do the desalination. So for that, from there, this termscape. So regular maintain about the plant discharge from the cooling towers, blowdowns or scrubbers, different type of things. So regulation are expected to keep the tightening and what is called this GLD method is nowadays widely used for environmental regulation on discharge of specific solids like salt or toxic element or nitrate, nitrite, etc. And water scarcity or water stress growing worldwide along with still negligible rate of wastewater recycling. And in the terms of economy, so recycling water becomes more affordable as compared to water supply from a conventional source. So these are the key advantage of GLD. So it is also, although this GLD its cost is high in most of the cases, but once you plant this key control setup, then it can long last, and you no need to worry about the water cycling all these things. So basically this GLD zero liquid, as it is L for liquid, so that means it is more applicable towards the liquid. So the answer will be liquid. Okay. So we can go to the next part of the question. Okay, so before going to the next question, so some of the part batteries we have learned in the class. So that things I just recalling. So there is broadly three type of batteries there, three categories. One is primary batteries, one is secondary batteries, other one is reserve battery. So what is primary battery? So primary battery is designed to discharge only. That means you have some battery which is you can use only one times. So it is already it is in the charge state, and you can just use at a time, so that after complete discharge you have to discard the cell. So whatever, if you see in the clock or somewhere some cylindrical cell is to there, so that cell when you will buy from the market and you put in the clock, After that, you use the battery for longer time. So after 3-4 months or 6 months, when the battery is what is called discharged completely, that time we have to discard. So that is called primary battery. And what is secondary battery? So secondary battery basically it is more means it is quite same to the primary battery, but the things the difference is you can recharge it again. So that means once you buy the battery and you use and it is completely discharged, then again you can charge it and again you can reuse it. So as long as the capacity is retention is there, then you can use the battery. When the capacity fade is there, that time after a long time you can discard the battery. Basically in our mobile nowadays, whatever battery is there, that is secondary battery, because initially you buy the mobile and you charge the battery. After that you are using the mobile, and when the charge is 100% complete, sorry, the discharge, or when the battery is completely discharged, again you are charging and again you can use the battery. So that is called secondary battery. And what is reserve battery? So reserve battery basically in which active materials are kept separated by a special arrangement, and it has activation device makes ready, and this battery designed for a long storage before use, so it has a long capacity behavior. Okay, so that is the key thing. So so some of the thermodynamics relationship with the battery, because what is called when you are using the battery in Bangalore, so that time whatever temperature is there, and when you are in Kolkata or it is in Delhi, the temperature is different. So that means the battery performance can be affected by the temperature and different thermodynamic parameters. So for this, there is a relationship between the potential of the battery with the thermodynamic parameter. So that thermodynamic parameter, one important parameter is the Gibbs free energy or del G, which is related to the cell reaction, is found is directly related to the electromotive force. That is del G is equal to minus ANF E. So this relationship, I think all people know. And del G also we know that del H minus T delta S. So that things we know. So on that this basis we can discuss one problem. So this is the temperature spelling it. So temperature. So what is the temperature dependence of the electrochemical cell potential? Each there is given four options. Option A is del G by nRT, and del H by nRT, del S by NF, and del S by NF. Okay, I think the here two options are same. I think there is maybe some mistake is there. So these two options, maybe one is NFR, I think. So what will be the answer? Okay, I think this kind of question also we have discussed in the previous class also. So okay, so this question, I think this is question number. Okay, there is no question number, but if people can write in the chat box, so I can see. So what is the answer? It will be. So whatever you know, just now we have discussed. So del G is equal to minus ANF E, or E cell I can write. So from there only we have to start. So this is there. Then after that, what we have know that Gibbs Helmholtz equation we know no. I think in BSc or MSc time we have learned Gibbs Helmholtz equation. What is Gibbs Helmholtz equation? Tell. del G is equal to del H plus T del delta G by delta T at constant P. Okay. So now we can write in place of del G, what you can write? Minus NF E shell. So this thing you can write, this is the equation 1. So del H plus T del minus NF E shell, because basically we have to calculate del E by del T at constant P, what it will be, because temperature dependency of the electrochemical cell potential, that means del E by del T at constant P. So how the potential of the cell is changing with thermodynamic parameters. So that things we have to find out. Okay, so this is constant P. Now in this equation, An and F, that is constant, so that can come out from the what is called derivative. So del H minus T N F delta E cell by delta T at constant P. And this is N F E cell. So now this term del H, what we can write? Del H is equal to, we can take out this thing here. So T N F delta E by delta T at constant P minus NF E cell, right? Now what you can write, NF, if you take it common, then what it will be? E, what it will be? Minus NF we can take common. So minus NF if we take, then E cell minus T del E by del T at constant P. And other things what we learn, this one, del H is equal to del G is equal to del H minus T delta S. These things we learn. So from here, if you calculate delta S, then what it will be? Delta G minus, okay, delta G minus delta H divided by T, it will be minus. Okay. So what you can write, delta H minus delta T by T. It will be delta G, delta S. Okay. So now suppose this one I can give some number. This one it is suppose this is 2. Okay. Suppose this is 2 and this is suppose 3 and this is suppose 4. Okay. Then from 2 and 4 what you can get? This one and this one. What you can write? Delta H, delta T, all these things if you put delta H, if you put delta H, this value here, then what you will get? Delta S is equal to NF delta E by delta T at constant P. So that means if you see delta E by delta T at constant P, that will be delta S divided by del NF. So this is the answer. So here you can see C is the delta S by NF. Okay. So this way you can proceed to these problems. Now we can go to the next problems, that is the Daniell cell. So how to Daniell cell represent? Okay, there is a Daniell cell. Basically, what we have learned, that a Daniell cell is the cell where you have two beakers and you have the one beaker you have contain copper sulfate and copper plate is there. This is the copper plate. And another container that is contain zinc sulfate, and there is another plate that is zinc, right? So now how to represent the Daniel cell? What will be the answer? Which one it will be the option? So zinc is going to zinc sulfate, and which is separated by salt bridge. So this is here, it is salt bridge. And zinc copper sulfate, copper 2 plus. And option B is copper 2 plus going copper sulfate, which is separated by salt bridge, zinc sulfate, zinc. And C, zinc sulfate, zinc, copper 2 plus copper. And option D, copper sulfate, zinc, copper 2 plus zinc sulfate. Okay, so Anil has written, I think, A. So Daniel said. Daniel cell. So what was the cathode reaction and what was the anode reaction? So if this is the cell configuration, then what will be the anode reaction? Anode reaction, zinc will go to zinc plus 2 plus 2 electron. This is the anode reaction. Anode where the oxidation will happen. And what will be the cathode reaction? Cathode reaction, copper 2 plus 2 electron it will accept, and it will go to copper not. Okay, so this copper 2 plus mean it is basically in ionic state, means copper sulfate. So if you write the whole cell reaction, sorry, so cell reaction what will be? So zinc plus copper sulfate means copper 2 plus copper sulfate, that is going zinc 2 plus means zinc sulfate plus copper. So in this Daniel cell, what is the EMF value? EMF value 1.1 volt. Okay. So if you represent this cell reaction, how it will be? Zinc is going to zinc sulfate. This is the oxidation, which is separated by what is called salt bridge. And then copper sulfate is going to copper not. So copper 2 plus, here 2 plus, and zinc 2 plus. So this is the cell representation. And here you can see option A, whatever Anil told. So that is the correct. So zinc sulfate is going to zinc sulfate. That is the oxidation, and copper sulfate going to copper. So that is the reduction. Okay. So this to all these cell reaction, as professor has mentioned, to remember or a little bit more focus, because in the exam they will ask from there what is the cell reaction for Daniel cell. So like basically you have to write what is the cathode reaction, what is the anode reaction, all these things. Okay, so that is the thing. Now we can discuss a little bit more on the fuel cell. So this is the thing. So what is the fuel cell? So fuel cell basically is the cell where electrochemical energy is converting. Basically chemical energy is basically converting the electrochemical energy, electrical energy. So it is basically available fuel oxidation system where the electrical energy by an electrochemical process, and in which this process, electrochemical process, where the fuel is oxidized at the anode side, and fuel cell works at high efficiency, and resulting emission level are far and permissible limit. So fuel cell are modular, and hence the that can be built in a wide range of power requirements for few hundreds watts up to multi kilowatts or even megawatt size. Also we can develop the fuel cell. So okay, this is the theoretical aspect. So basically your chemical energy, that is your heating, after that it will mechanical energy, and finally it is going to the electrical energy. Okay, and in the basic rearrangement or the cell representation of the fuel cell is that you have the fuel and electrode, and which is separated by the separate solvents and electrolyte, electrode and other oxidant is there. Okay, so this is the thing. Suppose you have the what is called hydrogen oxygen fuel cell. Then what will happen? So in the hydrogen oxygen fuel cell, you have a porous electrode, because you as you are hydrogen oxygen, so air or oxygen and hydrogen, that gas should come inside the cell, right? So for that you need the porous electrode. So I will discuss more about okay, that how why we need porous electrode, so when I will discuss more about the metal air battery. So at the end of this lecture, I will discuss more about that. Okay, and so basically you have some the cathode, porous cathode. You have porous, and you have anode, and in between basically you have the electrolyte, that is the KOH solution is to take. So what is potassium hydroxide as a electrolyte. So what will happen that in the cathode, what will happen, reduction will happen. So basically at it is what is called hydrogen oxygen fuel cell, hydrogen oxygen fuel cell. So what will you have the hydrogen as well as oxygen. So in cathode, what will reduction will happen? So what will happen? So O2 plus, as it is aqueous medium, so water plus 4 electron it will accept, and it will go to 4 OH minus. So this is the cathode reaction. What will be the anode reaction? Anode reaction, it will be hydrogen. You have hydrogen, so that hydrogen plus 4 OH minus, that will produce 4H2O plus 2 electron. I think these things we have discussed in last class also. So that means in the overall reaction, I can write here overall reaction. What will be the overall reaction? Basically hydrogen, you can add these two. So basically this part, so this part and this part, it will cut out, and water molecule, it will one water molecule here, 4 water molecules, so that will cut out. So basically what you will get, that 2H2O, H2 plus O2, because here H2 and here O2, so that will give you 2H2. Okay, so this will be 2. So 2H2O, here is 2 and here is 4H2O, so that will cut out. So this is basically water splitting, you can tell, because hydrogen and water, what is not water splitting, basically hydrogen and oxygen is recombined in electrochemical process, and it is forming the water molecule. So this is quite a classic example of hydrogen oxygen fuel cell. So now, and this fuel cell, basically you have this cathode, anode. This is the cathode, and this is anode. This is electrolyte. So your air or O2 is coming from this side, and from here anode side, here H2 is coming. So that means what are the phase you have. So basically this is the liquid, your cathode, that is solid. So and gas, water, that is the gas. So we have 3 phase, right? What is one is gaseous phase, Gaseous, I can write gaseous solid interface. To solid, this electrode and water, so that is solid liquid interface. And other is the liquid gaseous interface. Liquid gaseous interface, right? So this is the three key interface in fuel cell, or if you talk in air battery also, it has the three phase or three interface of different catalyst as well as the reactant. Okay, so on this basis, we can go to the next question. So how many types of fuel cells are there? Option A, only one. Option B, 3. Option C is 4. And option D is 5. I think these things it is discussed in in the class. How many types of fuel cells are there? Only 1, 3, 4, and 5. Which one will be the answer? This fuel cell we have discussed in the class. I think it is discussed. Okay, just a second. Drink liquid water. We have learned, no? Fuel cell, that is 5 types of fuel cell is there, no? First one is alkaline fuel cell. Which is called AFC. Second one is molten carbonate fuel cell. That is called MCFC. Option 3 is phosphoric acid fuel cell. All these things it is discussed in the professor lecture. So there means in details what is phosphoric acid reaction is to happen. So that things it is discussed. So I am not going to that. Just I am mentioning what are the fuel cell is there. Okay, phosphoric acid fuel cell. That is PAFC. Yeah, phosphoric acid fuel cell. And number 4, solid oxide fuel cell. SOFC. Number 5, proton exchange membrane fuel cell. Proton okay. So this is the 5 type of fuel cell. So that means the option D is the correct answer. Okay. So you people can remember this 5 type of fuel cell, because it may ask in the what is called in the exam also. So the next question is, a tertiary battery is useful only once, but with long life, as a battery with high voltage, as rechargeable battery, as reserve battery. What will be the answer? A tertiary battery is useful only once but with long time. So Anil has written D, so I did not get because in the last last question also it is D. So I hope that is this question or this question I did not get. So if for this question this tertiary battery is useful, so that is for this question, then you can write again. What will be the answer? I can give the hints. So basically, these things we have discussed different type of battery. Basically, primary battery, secondary battery, and reserve battery. So there we have three type of battery. Basically, we have discussed. No. Yeah, so it is a tertiary battery. Basically, it is a reserve battery because in this battery, tertiary battery. So basically, in this battery, you can store long enough ion, or in terms of lithium ion or battery. If you tell, then that is you can store maximum energy density. So that is called tertiary battery. So in that case, this is the reserve battery kind of what is called classification. Okay, so this is the question, and so this is a secondary battery is typically used only once, only twice, two times, multiple times, none of them. So it will be multiple times because we have discussed these things. So basically, what we have discussed that this secondary battery, basically it is kind of primary battery, but you can use the battery for as long as the capacity is not fading. So that is the thing. So secondary battery, so it is similar kind of primary battery, but you can use multiple time as long as capacity fading is not there. So after sometimes if there is a so much loss of capacity, then you can discard this secondary battery. Okay. So the question case 6. So what is the major disadvantage of evaporation ponds for GLD, zero liquid dispersion? So this is what is the disadvantage. So basically, it is option H, footprint area is large, not economically viable, takes longer time, and all of the above. So basically, this is GLD. This GLD evaporation as a pond. So this is basically conventional thermal GLD method technology or method. Okay. So what will be the answer? And it takes longer time. Footprint area is large. Okay, so Anil is telling takes longer time to evaporate. Yeah, that is also true. Suppose you have pond and you have different things, and due to the sunlight, it is evaporating. So that's why what is called it will take longer time. But other things. So because pond, it is quite big. It can be quite big. So if you people are from village, then you can see that in the village there is a big pond is there. So which in the summer season as well as in the winter season or entire whole year, the water can evaporate from the pond. So that is quite bigger area you need the pond. So because as the surface area of the pond will increase, the evaporation will be increased. So that means it is also finger footprint area is large also. So that is a kind of disadvantage because suppose you have some machine and you are 1 hour you are transferring suppose 2 liter or 3 liter of water and you are producing a pure water from that and that for that to locate that what is called instrument or that machine it will take very small area but if you see the pond it is quite big so if you think in the town or city it is quite impossible thing in village it is okay but with time when the population will increase the area will not get so much so that means this footprint area also one of the disadvantage and as well as what you can say that this front that is it is quite big area things so and it is not also economically viable so that means b option also correct that means the option it will be d okay and what other things we can know that this evaporation method or basically this thermal GLD so that is basically depend on the evaporation as well as crystallization evaporation and crystallization crystallization operation okay and in this evaporation method you can get 90% more than 90% of water recovery okay and this crystallization but in the crystallization method what you can get 100% of recovery okay so that is the things and what is called this operation or capital cost are quite high in this case this is also one of the what is called disadvantage because if you see one of the examples that 20 to 40 kilowatt of energy used to consume for desalination of water. So that is one of the things, and as well as the expensive corrosion resistance materials is required for the this method. So this is the what is called disadvantage. Now we can go to the next question. The conventional GLD operates on the principle of what? So option A is the distillation, option B evaporation, option C crystallization, option D size size separation. Okay. So we already discussed this all this point. So you can get you can answer this question. Conventional JLD operates on the principle of distillation, evaporation, crystallization, size separation. Just now I have to. I think what will be the answer? Conventional GLD, especially in thermal GLD also. That is also one of the conventional GLD. So what will be the answer? We have discussed here, no? Evaporation and crystallization operation. So what will be the answer? Option B and option C. Crystallization as well as evaporation. Okay. So you can go to the next question. Western cadmium cell is represented as, so this is basically all are the cell reaction. Cell reaction, I can write here, cell reaction. Okay, so how we can represent the Western cadmium cell? Okay, so what will be the answer? Okay, so Anil has written option B. Okay, we can details we can discuss. Yeah, it will be option B only. So basically, what is happening in the Western cadmium cell? So basically, you have the cadmium and mercury alloy, so that will cadmium amalgam and mercury, so mercury sulfate is there and cadmium sulfate it is to there, which can dip mercury on the mercury sulfate, and cadmium amalgam it is to dip in the cadmium sulfate. So what will be the anode reaction? So this is Western cadmium reaction, so anode reaction will be cadmium is going to cadmium 2 plus 2 electron, right? And in the cathode, okay. So in the cathode, it will be Hg2SO4 plus 2 electron. Reduction will happen. So 2Hg plus SO4 2 minus it will be. So if you write overall reaction, what it will be? Cadmium plus a sorry. Okay. Hmm. So what it will be? Cadmium plus Hg2SO4. In the left side we have plus water. What it will be, because this is aqueous solution, so what it will be? Cadmium sulfate plus water. So it will be, it is in the crystalline state, plus Hg. So here you can 2Hg is there, so 2Hg, here 2Hg is there. So 8/3, and this is also 8/3. Okay, so this is the overall reaction or cell reaction. So in this case, what we can represent the cell representation? The cell representation. So basically cadmium amalgam In general, this amalgam is 20.5% around. Okay, and it is separated by cadmium sulfate 8 H2O, because if you it is for multiply by 3 here, then it will be only 8. Okay, and then H2SO4, which is standard, and Hg electrode. So this is the cell representation. Here you can see this is the cell representation. So it is cadmium Hg, it is written. So basically cadmium amalgam it is representing. Okay. So that means the answer it will be B. Okay. So you can go to the next question. So zero liquid discharge system are required because environmental regulation on discharge of specific solutes are becoming stricter. Option B is water recovery is better. Option C economically affordable, and option D none of these. What will be the which one will be the answer? Zero liquid discharge. Okay, so water recovery is better. Yeah, that is one option. It will be more than one answer. What will be the other option? It can be. So because zero liquid discharge, this is what is called. You are basically desalinating the water or toxic hazardous material, no? So that means environmentally regulation on discharge of scientific solute are becoming stricter. So that will be the another option. Okay. So this option A and option B. Okay. But this GLD, there is so many what is called disadvantage also there. What we already discussed this thing. So we can go to the next problem. What are the things? So question 10, that is determine the amount of copper deposited in grams. When in grams we have to calculate when a solute of copper sulfate is electrolyzed for 15 minutes, a current of 1 ampere determine the it will be full stop here, determine the copper deposited at the cathode. So it is given, the molecular weight is given, and 1 Faraday value is given. Okay, so basically this kind of question we already discussed. I think first or second class maybe. Okay, I have discussed this kind of problem. I have what is called discuss this thing. So what will be the answer? So basically, what are the things it is given? You just see. Okay, Anil is telling that it is option C. Okay, will be the other things. So all people are thinking this option C will be the right. We can do together. So basically, what is called Faraday's law, we have to think. So Faraday's laws tell, what are the Faraday's law tell? Faraday law, that if you transfer 1 Faraday, then it will deposit 1 equivalent molar, equimolar, 1 equimolar of compound, right? So 1 Faraday means 96487 coulomb. That means if you pass 96487 coulombs of charge through some electrolyte, then if there is a material is there and that will deposit it, that is 1 equimolar of that compound. So if it is sodium is there, suppose, so then it will deposit it to sodium. So this is one electron process. That means if you pass 96487, then and if it is one electron process, then it will be 1 equimolar of sodium, whatever it will deposit. So in the case of sodium, as it is unimolecular, so it will be whatever molecular weight and 1 equimolar weight, that is same. But in the case of zinc or copper, that is copper 2 plus and zinc 2 plus. So that means in this case the equimolar and molar concentration are not same. We already know from the acidic solution or acid base K chapter, where in the case of HCl it is a mono K unit, so H plus and Cl minus is there. But in the case of H2O SO4, that is 2H plus and SO4 minus, it is to form. So in this case, the molarity and normality is same, but in H2SO4, molarity and normality is not same. Normality is not same. So this kind of thing we have to think. So this is basically molar concentration. This is equimolar concentration. So that way you can proceed in this problem. So basically what you are doing, so that means the molecular weight of copper 2 plus, it is given 23. So that means 96487. If you pass, then 23 divided by 2, that is 31.5 gram of copper will deposited, because copper is plus 2. So for this I am dividing plus 2. That is the equimolar gram. So now it is given that 15 minute 1 ampere current it is passes. So what do you know? Q, that is charge, that is I means current into time t, and this t it is in second. Okay. Now how much current this is I have to calculate. So this is 1 ampere current into time is 15 minutes. So 15 minutes into 60, that is second. So it is 900 coulomb. Now you can calculate this thing. So 96487, that is going 31.5 gram. Then 900 how much coulomb? 31.5 divided by 96487 into 900. What will be the answer? What will be the answer? Can anyone calculate? 31.5 into 900 divided by 96. Okay, so Ritambhara. So I don't know. Maybe I am not pronouncing it wrong. So Ritambhara, she telling that 0.2938 gram. Okay, so these things you have to remember, that equimolar, 1 equimolar gram of compound will deposit. So whatever Anil is written. So if I think he has taken this one as a mole. So these things you have to remember. So otherwise, this means it looks like the problem is quite easy, but in the exam, if it is come, then it will be a wrong answer because you have to consider that is equimolar. So the Faraday's law that is tell that when the compound of one Faraday of current it will pass, then it will be one equimolar of compound will deposit. Okay, so if it is aluminium, if it is there, aluminium 3 plus, so that means whatever what is called molecular weight of aluminium 27, so that divided by 3, so that much amount of aluminium it will deposit if you pass 1 Faraday of charge. Okay, so that things you people can remember. Okay, so now I think all the question it is discussed. Now I will discuss a little bit more about what is called different battery technology. So in modern time, how is the battery technology? So basically, why you need the battery? So that things we can discuss a little bit more. So because why you need the battery? So what are the challenges is there? Because nowadays what you can see that the CO2 emission or as the population is increasing and the CO2 emission is happening and energy consumption is quite high and but the source of the energy is limited and which can change the climate of the environment as well as due to the pollution also your temperature as well as the environment is changing. So that means we need something which can be renewable. Okay. So you can when you can tell the renewable energy or renewable energy source, what you can think that solar energy or wind energy, rain energy, all these things we can remember. But that are all are controlled by the what is called nature, right? So that means okay, suppose you are using the sunlight or solar energy, sunlight energy. So in the daytime you can use the sunlight energy, but in the night time you cannot use the sunlight energy, right? But as well as in the cloudy season or rainy season, there is no sunlight. That time you cannot use a renewable energy source. So that means we need something which can store the energy and it can save our world or our earth. So this is the thing. So what you can do that one of the option of these challenges to overcome is the electrochemistry. What is electrochemistry? So in the electrochemistry, basically two parts is there. Electro means electron, and chemistry is chemistry or reaction, chemical reaction. That means electron transfer is happening, and due to the electron transfer, chemical reaction is happening, or chemical reaction is happening. As the electron transfer is happening, that means the current you are getting, right? So that is the thing. So this electrochemistry is quite interesting that you can store the renewable energy source which is controlled by the nature that can be controlled by the human. So you can take the help of electrochemistry and that will give this what is called you can use that electrochemistry technology to store the energy. So when you are talking store the energy, there is different type of storing mechanism is there, means system is there. So one of the technology is battery. So we have discussed different type of battery like lead acid battery, nickel cadmium or nickel cadmium battery, and lithium ion battery, nickel metal hydride battery. So all these things, this diagram, so this is representing all are the secondary type of battery. Okay, so it is written C, that is cylindrical type of battery, and P is the prismatic type of battery. So here you can see, so this in this graph, but you can see that in the y-axis you have the gravimetric energy density, and in the x-axis you have the volumetric energy density. What is this gravimetric energy density and what is volumetric energy density? So basically, what you are doing that suppose you make a battery, and whatever capacity you are getting, or whatever power, basically watt, W is watt, that is the what is called unit of watt power, power unit. So whatever power you are getting from the what is called battery, and you can divide that value by the total weight of your battery, because whatever battery you can say nowadays, whatever what is called battery electric vehicle people are using. So Tesla, one of the big companies. So and as well as in India, Mahindra, all people nowadays are more interested in the electric vehicle development. So all this electric vehicle, whatever battery they are using, that is lithium ion battery. So in lithium ion battery, whatever battery is there, that capacity is quite high. So I will come to that point, that why lithium ion battery. Here you can see also that lithium ion battery, it is the this red bubble. So here you can see that the capacity or gravimetric energy density is quite high compared to lead acid battery, because in old days we people used to watch use this lead acid battery, where this black kind of box it is to there, like this 12 volt battery is to tell. So this is quite big kind of battery, and you used to put the water, so that H2SO4 is to there, so that H2SO4 level it is decreased, then the capacity of the battery will decrease. So for this is to add water. So that means the what is called this big battery, that is only for 12 volt battery. So that 12 volt battery, as the size of the battery is high, so the capacity is or gravimetric energy that is coming low. So that's why we need something which has low what is called uh, low volume or low weight. So in cadmium, mercury, all these heavy metal elements. So for this, when you are putting this material in the battery, the weight of the battery is increasing. So, but in the case of lithium ion battery, that you can see the lithium, it is the atomic number of lithium is 3. So the mass around 6. So that means it is quite lightweight, and the energy density of the lithium is quite high. For this, nowadays people are using more about the lithium ion battery compared to the lead acid battery. So here also you can see its volumetric energy density as well as the gravimetric energy density is quite high compared to the lead. So it is the lead acid battery, it is there, but lithium ion battery it is here. So for this, people are more interested on battery energy storage, so that they can control the energy storage mechanism, or energy storage renewable energy source they can control. Okay, so how you can calculate this energy density or power density? So this is the equation. So although this all are not the part of the course, but I think they can ask this kind of question, that how we can measure or calculate the energy density. So this is basically the formula. So basically whatever current you are getting with time, and if this is the potential or voltage of the battery, and you are dividing the what is called mass of the cell or mass of the battery. So basically here you can see, if your battery weight will increase, then your energy density, energy and energy density, that will be decreased. So that means we need something or cathode and anode material which is light weight. Okay, and in the case of power, so basically you are whatever how much time you are running the battery or charging or discharging. So with that T naught to T naught is the initial time, and TA is the final time, and you are multiplying what is called IT and key potential or voltage of the battery divided by your mass is there, but with time how you are getting the energy, or how you are getting the energy with time, so that is called the power. So basically nowadays people are using what is called a hybrid battery, hybrid vehicle. So in a hybrid vehicle what it is to there, that you have the petrol as well as what is called battery also. So initially the engine will start by the petrol, because that time we need high power. So and after starting the what is called vehicle, you can use the battery for the running the vehicles, as well as there is also hybrid battery also there. So hybrid battery is basically capacitor as well as battery mechanism is there. Hybrid battery. So basically there is the capacitor or super capacitor, I can write super capacitor plus battery mechanism. Okay, so what is happening? This means hybrid battery, why people use in the vehicle, because during starting the engine you need high power. So this capacitor or supercapacitor, basically it is accumulation of charge, and in the battery or ion battery whatever. So that is what is called ion intercalation is to happen. Ion intercalation. So I will come to what is intercalation, all these new terms. So I will introduce all these things. So basically, ion intercalation is to happen. So this is slow process, but in capacitor, basically your charge is what is called accumulated on the surface. So you can take easily that ion from the surface, and again you can what is called easily give the charge on the surface. So and for that you will get high power with a small time, because with a small time you are getting the high energy. So for this ta minus t naught, that is very small, so that means you have the high power, right? So this super capacitor, all this thing, you will get the high power. So for this in vehicle, all this thing, people use the hybrid battery, which can give a combination of super capacitor and the battery. Okay, so this is the thing. So now we will discuss. I think these things we already have discussed. Daniel case cell. So and other thing, I'll introduce some of the things which already we have discussed, like group Bunsel case cell. So I am not going to all details, but I just write all these things so that with so we can discuss how the battery is developed, right? So Grove Bunsen cell. So this is a Grove Bunsen cell, where you have basically the cell reaction is like this: zinc and 8% you have to H2SO4, which is connected by salt bridge, and 60% of HNO3 is to take, and we have the platinum. So this is one of the electrodes. So this is the Grove Bunsen cell, where here zinc is going to zinc 2 plus, and water is there. So and other cell is it is called bichromic cell, bichromate cell. So what is bichromate cell? Basically you are using the chromate. So here you have the zinc and chromic acid. H2CrO4. Okay, and you have what is called the other thing is the H2SO4 and water and carbon you used to take. So basically total 100% is used to. So this one it is called 22%, and this part it is the 18%, like that. So in this case also zinc basically it used to go to zinc 2 plus, and chromate that will reduce to what is called chromium 3 plus. So because it is here what is called plus 7 oxidation state I think. So basically chromium Cr2O3 2 minus Cr3O O chromic acid. So basically O7. So O7 2 minus plus 14H plus 2Cr3 plus. I think this equation we learn in the what is called during the titration chromic acid titration. So that time we have is to familiar with this reaction, right? So this is potassium chromate. So this is one of the question. Other cell it is there like Clark standard cell. So this is also zinc amalgam it is to it. I think this thing we can cell also this cell also we can cadmium cell we discuss. So this is also similar kind of cell. So other we can cadmium I can write western, sorry, not vision, western cadmium cell, cadmium. So mercury amalgam it is to form. So sorry, cadmium amalgam it is to form, and mercury sulfate it is to use in the solution. And more familiar what is called cell, that is the carbon zinc cell. Okay, so all these things we have discussed in the class. So I am not going to details in that. This is one of the familiar picture I think we have discussed in the in the class. That is the Carter view of carbon zinc cell. I think this cell is to use so much in the torch. In earlier days, people use this primary cell in the torch. So basically, you have the zinc zinc jacket. It is to there. So zinc can where that is used as a anode material, and other things. This is on rod, that is the positive electrode it is to. So and these things is the manganese oxide, manganese dioxide, and carbon electrolyte it is to there inside, which is separated by the zinc zinc jacket. So this is one of the what is called um, one of the cell zinc cell, basically alkali cell. So cylindrical like cell. So there is another, that is I think nowadays also people use this kind of cell. I think it is quite huge in camera, all these things. So here I think all these things here also zinc used as a anode, because zinc is quite cheap material. So can carbon conductive coating also there. So these things I think we already have discussed in more in the class. I'm not going to discuss more about that, but alkali, this is one of the alkaline cell. So basically you have the sorry, this is the anode gel powder, and here is the metal brush for one connection, and other connection it is here. So and you have the cathode materials, and in the cathode material we have manganese dioxide, carbon electrolyte, and current collector. Basically, as I have mentioned, this is the current collector, that is the brass material, and what is called separator, nanofabricated electrolyte, this is the separator. Okay, So this is one of the what is called cylindrical alkaline cell, and so in the this is one of the card view of the miniature alkaline cell, or we used to call is a coin cell. So coin cell, where you can see in the watch or different small gadgets, you can see this kind of cell cap coin cell. So I think in our lab also we used to do when we are doing the research or developing the battery. First we used to study in coin cell. So I can show this picture in Monday that what are the part is there in the coin cell and how people used to assemble this coin cell. So that things I'll show in the Monday the video. I can make the video in our lab, and then I can show that things so that you can get some idea that what is there inside the coin cell. So in this also you can see that there is a jacket. Basically, this is usually stainless steel or conducting jacket. It is to there, and here some insulating layer is to there, so that your one connection is here. Suppose this is cathode connection, cathode current collector, and this opposite side it will be anode current collector. Okay, so that means should not be any touch between the cathode and anode. If there is it will touch to cathode and anode, then your cell will be dead. So that your cathode and anode will be separated by the separator. And this part, so you can see this is the insulating layer, this black kind of thing it is there, so that your cathode side and the anode side it is not touched to each other. So that way, this cell is made. So there is another thing is the air cell. So air cell, I will show more details in the schematic. So basically, you have one side is the porous side it will be, and other side you have the anode and cathode side that will be porous, so that your air or other things, whatever gaseous reactant that can come and enter in the cell, and some electrochemical reaction can happen, right? So that is one of the KOA. So now question, what is the recent time why people are interested in lithium ion battery? Okay, so here this is the energy density diagram, that is watt per kg. I already shown how you can calculate what are the formula of to calculate the energy density. So here you can see there here different type of battery it is representing. So one is this is the lithium ion battery, and ASIB, that is sodium ion battery, like that zinc ion battery, calcium ion battery, aluminum ion battery. So all these ion battery is there. So in this diagram you can see, and this is A, that is only on anode, means on the depend on metal, because you can calculate the capacity or energy density on different component, like you can calculate only on anode, you can calculate only on cathode, you can calculate overall cathode and anode, you can take and you can calculate. So this A value, so that is only on anode, and B, that is only cathode, and this C, that is anode plus cathode. So both have taken, and after that calculate the energy density. So in this diagram you can see that for lithium ion battery, you can see in all the cases its energy density is quite high, right? So for that, people are more preferable to use lithium ion battery, because you can what is called small volume of your ion battery, that can give you higher energy, so that if you see in our mobile or something, you can go today, you can check in the Amazon or any other mobile buying website. So they are in the specification of the mobile, you can go and you can check that what is the battery they have used. So you can see that there is a lithium ion battery or lithium polymer battery, it will be mentioned, and what is the capacity of the battery. So when you used to buy the battery, that time we used to see that how much capacity of the battery, 5000 mAh or 6000 mAh we used to see. So depend on that we used to buy. Okay, if you buy the 5000 mAh battery, that will last for longer time because the capacity is high. So that way you can see. I think that picture also I have that I have taken from the Amazon website, that one battery mobile specification. I think maybe Samsung Galaxy something, some model. So there it is mentioned that which battery they are using. So and what is the capacity. All these things you can get from the website. Okay. So from here, what you are seeing that basically this lithium-ion battery, that is quite high energy. So this is the schematic of lithium-ion battery. So I will discuss more details of this, how uh, these things is happening. Okay. So and for this energy storage or lithium-ion battery development, so people get the Nobel Prize in 2019. So these three key person got the Nobel Prize. So this one, he is the John Good enough. He is, and this middleman, he is the Stanley Whittingham, and this left one, he is from Germany. Sorry, Japan. He is Akira Wasino. So these three person basically developed the lithium-ion battery. So for their contribution to energy storage, they got the Nobel Prize in 2019 for lithium-ion battery development. So now I think this two-person is alive. Recently, I think last year, Sir John Good and passed away. So he is, I think, 101 years or something. He alive. So these two-person still there. So they got the Nobel Prize for developing the lithium-ion battery. So this is the example where you can see the electric vehicle market diagram. Here you can see this one is representing the hybrid plug-in hybrid electric vehicle, and this one is the battery electric vehicle. So in Bangalore also, when I go to outside, so many electric vehicle bus, public transport basically it is used. So you can see that 2020 there is no only 2021 1.75% of what is called electric vehicle is there. But in 2023, you can see 6.38% it is increase. So it is means whole India now are more focused on electric vehicle. Okay. So here you can see in bar diagram within 2030, so it will be almost 80 to 90% all the electric vehicle that will be in it will be in battery. So that means people are more focused or to use the renewable energy, because nowadays as the weather, all these things are changing, so it is the good time to concentrate on the what is called renewable energy source, depend on the renewable energy source. So this is the some of the top electric vehicle company which is in India. You can see Tata, Mahindra, Toyota, all these company, they have developed the research and development sector for electric vehicles. So you can see Hyundai, that is 14%, and these things, most of the other things, Toyota, all these people, they all have contributing or more focus on the electric vehicle sector. Okay, so that means you can understand how much important this battery system. Okay, so I can show you. So this is the picture what I am telling that this is from the Amazon website. So this is Galaxy S24 Ultra 5G smartphone. There you can see what are the specification it is given. So here you can see what battery they are using, lithium ion battery they are using. So and all other things it is you can see that whatever battery it is there inside the what is called mobile, that is square kind of thing. So that it is to call spout cell. So I am not discussing here the pouch cell, but there is different type of cell is there. So basically cylindrical cell, whatever you use in Daniel cell or in clock, whatever can Nippo company battery you use. So that is cylindrical cell, and in hand or clock we use coin cell, very small cell, that is coin cell. And in mobile, if you open the mobile, square kind of battery is to see. So that is called pouch cell. Okay. So now we can see that what are the why how the lithium ion batteries to work. So basically, you have a cathode where you have lithium metal oxide is there, like layer kind of structure, and in the anode side you have the graphite. So we know the graphite, which is carbon material. One layer, after that another layer is there, and in between two layer you have the pore, or you have the vacant position, so that lithium ion can intercalate. Basically, intercalation means the ion is just going to the vacant place, and again deintercalate means it is again coming from the what is called vacant place, and it is entering after from there it is coming out from the place. So that is the intercalation and deintercalation. So intercalation means it is entering in the host material, or it is entering in the house or room, you can say. And what is called when intercalation means it is coming out from the room, that kind of thing. Okay, in easy way you can understand. But this lithium ion battery, whatever we are telling, there is some limitation. Not say although it is commercially available, but the energy density of the lithium ion battery is quite low. So in compared to other things, because why you are using gasoline? Because you can see the gasoline energy density is 1700, but here whatever lithium ion battery, this is the practical data. So practical energy density. So here you can see the lithium ion battery 160. So that means how much low of this lithium ion battery. For these people are using gasoline or fuels in vehicle, because this energy density is quite high for gasoline, all these things. So that's why. So when you are developing the electric vehicle, that time what will happen? So means suppose in fuels or petrol car, what will happen? Suppose you are going for 200 kilometer or 300 kilometer. After that, suppose your petrol is finished, you can go to the petrol pump and you can take the petrol and you can go. So that is 5 minutes job. But in battery case, suppose your battery capacity is quite low, then what will happen that if you have some battery charging station, but you need time to charge the battery, right? So in the mobile case also you can see that in the to complete or full charge it need at least 30 minutes if it is a very fast charging battery, or 2 hours 3 hours it is to take. So when you are taking the car and you are going and 2 to 3 hours you have to wait to charge the battery. So that is not a practically what is called user friendly. So that means we need some battery which has very high energy density and very high capacity, you can say. So for vehicle, that is the limitation of lithium-ion battery. What its energy density or specific energy is 350 watt per kg, right? So you need some battery which has the higher energy density. Here you can see lithium sulfur or air battery, basically metal air battery, which has very high energy density. In the case of lithium air battery, you can see it is around 1700, means in compared to lithium ion battery it is 10 times higher. 10 times higher, right? So if we can commercialize the metal air or lithium air battery, then what will happen that it will be just boom on the market. So if means you can think in practically that whatever ion battery you are using in the mobile, so that things it will run for 1 day, let's say in the initial state. But if you use the metal air battery, that will run for 10 days because it is 10 times higher the energy density. So that's why you can say that in next generation battery, you can say this lithium sulfur or redox flow battery or metal air battery. So that all are the next generation battery. Although it is not commercialized yet, but it can be commercialized someday and it will be like very high energy density. So in for vehicle, you can use metal air battery because in that case also metal air battery lightweight it will be. So you can see in Tesla car the baseline wholly fully kept the battery. So the weight of the car is high. So that the what is called the mileage of the car will be decreased. But if you use the metal air battery, then the weight of the battery will be low. So the mileage of the car will be high. So that is one of the key point to study in the next generation battery. Okay, so and this is one of the bar diagram where you can see all the metal air battery, different type of metal air battery like iron air battery, zinc air battery, magnesium air battery, aluminum air battery, lithium air battery. So all different kind of metal air battery is there. So and this is the reference. I hope. Okay, you people are from maybe BSc or MSc backgrounds, then it will maybe different. So basically, this first, this is the name. This Girish Kumar, that is the scientist name, and et al. That is means that is the group of people and Journal of Chemical Physics later. So this is the journal name. Basically, this is the research article. So when you are doing the research and you have invented some new materials or new things that you have to publish to the science community. So for publishing the towards the science community, there is different type of journal, scientific journal is there. So one of the journal name is Journal of Physical Chemistry Letters. So this is the journal name, and 2010 means which year it is published. So that is the name, and one is the volume number because the whatever article you are publishing that will be in the volume or what you can say that book kind of thing, and this is the page number of the article. Okay, so this is the research article. If you people enter in the research line or if you do the project in electrochemistry or any other field also, so this research article you will get to know that what are the things representing. So if you take this information and if you search in the Google, then they will give the research article whatever information I am telling, so that information you can get all this research article. Okay. So from here, what you are seeing that lithium air battery, which is quite high energy density. Okay, so this is the thing. So and here you can see lithium sulfur battery, which is also quite high energy density. So one of the example now means lithium ion battery. It is already commercialized, but nowadays people are more focused on the lithium sulfur battery. Sorry, metal sulfur battery, which is quite high energy density. So what is how the configuration of metal sulfur battery? So basically you have the anode, that is the metal. Okay. By the way, okay, forgot to tell that in metal air battery, whatever lithium ion battery or all these things commercialized, there people will not use pure lithium metal. Pure lithium metal they did not use, because this lithium metal, which is what is called when you will expose to air, it will react with the air, and your whole lithium will go bad, right? So and it can cause fire also. So for this, what people used to do, they used to do some host material which can host the lithium ion. In the case of lithium ion, people use graphite, because you can lithiate it graphite in the layer of intercalation inter layer of this graphite, interlayer of this graphite. You can store the lithium, and that thing you can use as a battery material, so that when you will discharge or charge, lithium can intercalate and deintercalate in lithium graphite layer. Okay, so this is kind of one of the metal sulfur battery. So basically you have the metal, like if it is lithium sulfur battery, then you will take the lithium metal. If it is sodium sulfur battery, then you will take the sodium. And in cathode side, you will take the sulfur cathode, so that you can mix with carbon sulfur cathode. And in between you can take the salt, like sodium salt, lithium salt, like lithium perchlorate or sodium perchlorate salt, as well as lithium TFSI. So these all are TFSI. These all are salt basically, sodium TFSI. So these are different kind of salt. Okay. So these things. So basically, what will happen? So this is the cyclic voltammogram. I have shown one class. I have discussed that this kind of dark kind of shape it is to happen. So you can see. So this is what is called. So this is reduction, and this is oxidation. Okay. So lithium ion battery, whatever that is, intercalation, deintercalation is to happen. So basically, what is to happen? So lithium ion, I can write lithium ion intercalation, intercalation, and deintercalation. And lithium sulfur or metal sulfur, I can write metal sulfur or metal air surface conversion and decomposition. Surface conversion decomposition means some reaction or some product is converting. In lithium ion, basically what lithium is going inside and again it is coming. But in this case, sulfur will go to different product, and after that again it will come to the initial product. So this is basically the what is called charge discharge diagram. Discharge charge diagram. Okay, so here you can see in the x-axis you have the capacity, and y-axis you have the voltage. So here you can see that you have this kind of straight line. So basically this is representing that during the discharge, so this is the discharge. During the discharge, you are what you call sulfur, that is producing polysulfide and different oxidation state of sulfide product, like S8 2 minus, S6 2 minus, S4 2 minus, like lithium sulfide at the end product. So this is the discharge product. So this is reduction of the sulfur is happening. And in the oxidation, that is the charge process. So this charge process is the oxidation. Okay. And discharge process, that is reduction. So when people will tell that the battery is discharging, that means it is basically reduction is happening. And when we are charging the battery, that means oxidation is happening. Okay. So here you can see in the charging process, again the reverse process is happening, and at the end, when the complete charge is complete, sulfur is formed. Initially it is sulfur, and after charging it will be sulfur. Okay, and after complete of discharge it will be Li2S, and these things is happening. So this is the sulfur battery. So now we will talk about the air batteries, one of the familiar battery, or people are more means commerce try to commercializing, that is the air battery. So one of the air battery, that is zinc air battery. So this is aqueous zinc air battery, basically aqueous zinc air battery. So this is aqueous zinc air battery, what people used to take. So zinc foil, that is anode, and in the cathode side we have the porous cathode is there, so that air can come to from the this state. So that means you have the air, that is the gaseous state. You have cathode material, that is solid state. Air electrolyte, that is KOH, people used to use KOH. So that 6 molar KOH people use. So that is electrolyte. Okay. So that is liquid. So three phase is there. I already have just mentioned that in the case of air battery, we have the three phase or three interface is there. One is air, gaseous phase, one is solid, and one is other one is liquid. Okay. So what is to happen? So during the discharge, ORR is to happen. ORR means oxygen reduction reaction. Okay, and so what is in the cathode side? O2, it will reduce to OH minus, it is to form, and it will go to the electrolyte. Okay, and zinc anode is there. So what will happen? It will react with the zinc, and zinc hydroxide it will form, and this zinc hydroxide further convert to zinc oxide, and the overall reaction it is happening. So this is a discharge reaction process. And what will happen in the charge reaction? So O is minus, it is converting. So O charging process, OE are happening. Sorry, oxygen evolution reaction. So oxygen evolution reaction is to happen. So that things is happening. O is minus O2, that is 2 it is forming. So initially your air is there. So after reduction you are getting, after charging you are getting O2. Okay. So that means whatever you are getting initially, you are giving, after charging you are getting the same thing. Okay. So that is the air battery function it used to happen. So this is non-aqueous metal air battery. So it is written calcium, magnesium, but any metal. So lithium plus or sodium plus, anything it can be, or aluminum 3 plus. I have shown that different type of metal air battery can be possible. So this is one of the schematic. So basically you have the metal cathode and your porous side, so oxygen can come, and through the porous side it can go. So but the things is this O2, ORR and OER. So this is not a facile process. This is sluggish kinetics. So for this to facilitate this reaction, people use catalyst. Okay. So there is two type of catalyst is there. So catalyst you can use. So basically two type of catalyst. So one is electrode catalyst, another one is electrolyte catalyst. Actually, these all are advanced kind of thing. I just give the brief introduction so that when you are entering in any research, or when you are heard something related to battery, then you can get to know that okay, these things we already heard there. so that it you can correlate about this. Okay. So one is electrode catalyst, other one is electrolyte catalyst. So electrode catalyst means you are using the catalyst in the electrode surface, cathode surface you are using. Okay, here. So that is the electrode catalyst. This is solid catalyst. And electrolyte catalyst means you are using the catalyst in the electrolyte. So this electrolyte catalyst that also called the redox mediator. Okay, so I usually used to work on this redox mediator as well as electrode catalyst for metal air battery. Okay, so some of the example I can show. So this is one of the nice example. So actually, okay, this is one of my colleague have done these things. So basically, this is the heme protein we have used as a redox mediator or electrolyte catalyst in metal air battery, basically lithium air battery. So basically the idea is that we know that this hemoglobin from the school time we know that this hemoglobin which is known for oxygen carrier, right? Means in when you are breathing or breathe out. So when you are breathing, we are taking the oxygen and it is going to the lungs, and from there it is transferring through the blood to our different part of our body. Cell, basically different cell, it is going, and that oxygen is basically carried by the hemoglobin atom, hemoglobin enzyme or hemoglobin protein. So, and during when in the cell, what is coming? So when it is going oxygen, CO2 is coming from the cell, and again this hemoglobin that is carry the CO2, and it will again coming to the lungs, and when we are breathing out, that CO2 is going to the from our body, and myoglobin, which is known for the oxygen storage, right? I think all these things we know. So the same idea we use in battery, metal air battery. So whatever we air battery, what it is happening. So when discharge is happening, your oxygen is coming from the porous side and it is going to the battery. I think here. So in battery, what is happening? That your oxygen is coming and inside the cell, and reduction is happening, and when charging is happening, so oxygen is coming out from the cell. So it is kind of same kind of behavior happening whatever our body it is happening. So if you see, so this is the schematic that human breathing process, and here also in the battery, metal air batteries, the same thing is happening. So basically this heme protein that is using as a redox mediator. So in our body also oxygen transporting it is happening, and in battery this heme that is also acting as a oxygen transporting agent as well as redox mediator, means it can transfer the electron also. So that things it is used. So here you can see that this red one that is the hemoglobin, and this blue one that is the hemine, and this one without any catalyst, any catalyst. Okay, so there you can see that these things, the capacity of the battery is quite high, 4,000. Earlier it was 2,000, but now it is 4,000. So it is what is called two times higher than whatever capacity. So this is one of the interesting example where means whatever in our body it is happening. So and that things it is happening inside the air battery also. So, and after that, what I did, so in the porphyrin, I think hemine structure we know. So this similar kind of structure. This is the metal thylacynine, which is well-known compound for color or dye material. So hemine, this is hemine. If you know the structure in biochemistry, so similar kind of structure. Okay, so in hemine there is no this benzene ring is not there, so that kind of thing. Okay, so what I did, that I have taken different transition metal complex and I have used in the similar kind of this metal air battery, which can enhancing the battery performance. In that case, we are getting around 10,000 12,000 capacity. Okay, 12,000 capacity mAh per gram. Okay, so I can it is I can write here. So this is 10K to 12K mAh. Okay, we get. Okay. So this is okay, one of the research article what we have published already. So this is means quite interesting that in future okay, energy storage mechanism or it is quite interesting that if we commercialize this metal air battery, then what is called the energy crisis can be minimized. Okay, so this is up to now whatever we are discussing, this is all these things on battery. So last part of the lecture, okay, basically a little bit advanced thing. So whoever in MSc level or third year of BSc, so they can get some idea, or but if you are in 12 standard, so then it will be little bit not so difficult, but this kind of thing is happening and in future people are okay, doing this thing. Okay, in future also people will do, and now also people are more interested in high energy storage okay, battery. Okay, so that's all. Thank you all. So if you people have any question, then you can ask. Okay. Anyone have any question? You can share this copy. Okay. So okay. So if anyone don't have any question, then I think we can conclude the session. Thank you all for joining the class. Have a good day. So we can conclude the class. Okay. And we will meet again on Monday. So in Monday, we'll discuss some of the CV measurement, how we used to do. So that video I will show, and how this coin cell, what are the part is there inside the cell, that things I will show. And whatever we have discussed, that thing we will summarize. Okay. So thank you all. We can conclude the meeting. Okay. See you on Monday and the same time.